Hi, I'm Larry Karnas, and I'll be your instructor for installing an operating system into a VM. Got questions or comments? Please use the question comment box at any time. Now let's get started. Okay, in this chapter we're going to take a look at virtual machines. Specifically, we're going to see how to get an operating system installed into a virtual machine. So we'll see virtual machine remote consoles, we'll see the mechanics of installing an operating system into a virtual machine, and we'll see the role played by VMware tools once our OS is installed. A remote console is an application that VMware provides that gives me full console access to my running virtual machine. So in this particular screen grab, what we see is a Windows virtual machine in a window. So you'll notice it has all the normal Windows components. It has the start menu, the start button, it has the quick launch icons, the system tray, and so on and so on. And we've got a little application running in the background that paints all the key critical operating system properties on my background wallpaper. Now, my remote console application has some key functions. Using these icons here, I can power off, I can power on, I can suspend, I can resume my virtual machine. I can send a Control-Alt-Delete to the virtual machine. I can do that in a number of different ways. I can use Control-Alt-Insert, so in the virtual machine itself, if I hit Control-Alt-Insert, the remote console application will send a Control-Alt-Delete to my virtual machine. Or I can hit the VM menu, drop it down, and select Send Control-Alt-Delete as a menu option. Now, the VMware Remote Console application has the following features. It is active while the VM is powered on, even if the VM is booting. That means I can interact with the VM's BIOS. I can send a Control-Alt to release the mouse. When I click into the virtual machine's remote console window, the mouse becomes captive in that window. I can move the mouse in the window, but the mouse won't want to leave the window. If I get into that situation, hitting Control-Alt on the keyboard will actually release the mouse from the virtual machine's console window. Now, when I boot a virtual machine, the virtual machine will post. It will go through its power on self-test. While the machine is posting, you'll see menu options at the bottom that allow you to do things such as go into the virtual machine's BIOS. So if I hit F2, I can go into the VM's BIOS. I can set up the virtual machine, change the boot order, and change other properties of the virtual machine. If I hit Escape, I can get the one-time virtual machine boot menu. And if I hit F12, I can force the virtual machine to PXE boot. PXE, or Pre-Boot Execution Environment, is a network boot service that you may have available on your local network. Now, the remote console application adds a little bit of latency. And the problem with this is the following. The keys that we've talked about above, F2, Escape, F12, by the time I actually see the virtual machine, read the screen, and hit the key, it may be too late for the key to take effect. That's a bit of a bother. So I can change the amount of time the virtual machine sits at the power on self-test so that I have time to hit those keys. And the way I do that is I hit VM in the menu bar, I go to the VM's Edit Settings option, I then go to the Options tab, I select the Boot Options item, and I change the power on boot delay to the number of seconds that I want. I find personally that 10 seconds is enough. So here's an example of a VM that is going through its power on self-test. I can see that it is a BIOS power on self-test. I can see the I can see the BIOS boot menu. I can see the countdown timer over here. So I can see that I hit F2 to go into setup. I can hit F12 to do a network boot, or I can hit Escape for a one-time boot menu. Now, how do I install a guest OS into a virtual machine? Well, what I do is I take a powered-off virtual machine that I've just built. I take the install media and I connect the install media to the VM's virtual CD/DVD reader. Now, I will have to edit the VM's properties to point at the appropriate media image. To do that, I select Edit Settings. That is, I go to the VM, I edit its settings, I select the CD/DVD drive 1 device, and then I change its properties. Now, the default boot order for a virtual machine is hard disk first, but for a brand new virtual machine, the hard disk has no structures. It has no partition table, and it has no MBR. So attempts to boot off the hard disk will fail. The second boot device by default is the virtual CD-DVD reader. And if I've gone through the steps above to associate install media with the CD-DVD reader, the VM will boot off the CD-DVD reader, which is to say it will boot off my install media and launch the OS installer. If I don't have the CD-DVD reader connected to media, the BIOS will go over to the floppy device and try to boot from that. And if that doesn't work, it will try to PXE boot, again, pre-boot execution environment, boot off the local LAN. Now, let's assume that I've connected a install media image of Windows 2003 Server to my virtual CD-DVD reader. I power on my virtual machine. It tries to boot off the hard disk. That fails. It tries to boot off the CD-DVD reader. That succeeds. And it launches the Windows Server 2003 Enterprise Edition installer. And this is the first step for the installer. Okay. Now, if I install Windows, one of the jobs that Windows has to do is identify and bind drivers to hardware. If I install Windows on virtual hardware without installing any third-party drivers, Windows will install, boot, and if I go into Device Manager will show me that Windows has correctly identified and selected drivers for 100% of the hardware that the virtual machine presents to Windows. That means that all of the virtual hardware that VMware provides to a VM is easily identifiable and fully supported by the guest OS as native drivers. However, VMware Tools is a driver set that offers a better set of replacement drivers for virtual hardware. VMware Tools needs to be installed while a privileged user, that is an administrator, is logged in to the guest OS. So it needs to be launched while you're logged in. It cannot be launched from a login prompt. Okay. VMware Tools drivers improves the performance over the stock OS drivers. VMware Tools includes an enhanced video driver for snappier video performance. It includes a better virtual mouse driver for snappier mouse performance. It includes a virtual NIC driver so that we can run our networks at higher speeds. And it has an improved virtual SCSI host bus adapter driver for better disk performance. VMware Tools shows up as an icon on the system tray. And if I double-click that icon, I get this multi-tabbed interface where I can interact with VMware Tools. So you'll notice that the options I have available are time syncing, showing VMware Tools on the taskbar, that is the system tray, and automatic notification if there's any updates available for VMware Tools. Now, VMware Tools also adds some additional drivers that it turns out are critical for virtualization. VMware Tools installs a heartbeat driver. A heartbeat driver is a way for the VM to tell the VM kernel, I'm here, I'm healthy, I'm alive, I'm running. That is, I'm not locked up, I'm not crashed, I haven't failed. It includes a file system sync driver. The file system sync driver takes messages from the VM kernel, and those messages are usually sent in just before a snapshot. So the VM sync driver is responsible for posting all pending writes to disk so that snapshots contain a true image of the disk state at that moment in time. The VMware Tools includes a CPU status driver, and the CPU status driver simply reports the busy idle status of the virtual machine back to the VM kernel. The purpose of the VM CPU status driver is to tell the VM kernel which VMs at any moment in time are busy doing real work and which VMs are idling. And this has a major impact on scheduling. Simply put, the VM kernel will focus its physical CPUs on VMs that are doing real work. So those jump to the front of the run queue. VMs that are idling, well, they're not quite so important. They're not doing anything. So they get put at the back of the run queue. And a memory management driver is also included in VMware Tools. And the memory management driver allows the VM kernel to do dynamic memory rebalancing. In other words, to take memory from VMs that are now over-provisioned and give that memory to VMs that are memory starved. Now, a key feature of VMware Tools is the time sync capability. And the time sync capability goes back to the Service Console. Remember, the Service Console owns the physical server's hardware timers. The Service Console is also likely synced to an NTP time source, so the Service Console's time would be correct. Since the Service Console's time is correct, it makes sense to time sync my virtual machine with the Service Console, because if the Service Console's time is correct, and I sync my VM time to the Service Console time, by inference, my VM time will be correct. So it is a best practice to actually click the time synchronization checkbox to keep my VM time correct. The risk is if I do not time sync to the Service Console, my VM may lose clock ticks and its clock may drift backward in time. So time syncing delivers virtual timer ticks to the VM whether it's running or not, and it allows the VM to maintain an accurate clock at all times. And this works with win time, or it can work in place of win time. Now, what about removable media connects and disconnects? So I could have media in my physical CD/DVD tray, or I could have ISO images that I can connect to my virtual machine's virtual CD/DVD reader. I also have media that I can connect to my virtual machine's floppy reader. And I also have virtual NICs that I can plug or unplug into virtual switch port groups. And I can connect or disconnect virtual CD, DVD, floppy, or networks, that is NICs, at any point in time. And I can do that by using VMware Tools, which just allows me to say it's connected, it's disconnected, or by using Edit Settings, which allows me to not only connect and disconnect, but also change the properties of what I connect and disconnect to. So here's the VMware Tools side of things. If I go to the Devices tab, I can see my CD reader, my floppy device, and my NIC. With a checkbox in place for my NIC, the operating system would see the NIC as having a link to its virtual switch. If I uncheck this and then checked Apply, then what would happen is the operating system would see my virtual NIC as being disconnected from the virtual switch. It would have lost link. Likewise, for my CD reader and floppy, if I check either one of those items and then say Apply, that says report to the operating system that there's media in the tray and it's available for use. If I uncheck and then Apply, that says to the operating system, report to the OS that the tray is empty. Now, what about supported guest operating systems? Because VMware virtualizes at the hardware layer, VMware supports an extremely wide range of operating systems, including Windows going back to the old Windows 16-bit 3X and 9X days, 32-bit Windows, and also 64-bit Windows. So there's support for Windows NT, Windows Server 2000, 2K3, XP, Vista, 2K8, 2K8R2, and Windows 7. So not only Windows 7 Home Edition, but also Premium, Ultimate, and Enterprise Editions. There's support for 16-bit Windows, including Windows 3X, Windows 9X. There's even support for MS-DOS. And you could scratch your head and go, well, why MS-DOS? And the answer is there's somebody out there running some application that depends on MS-DOS even today. What about Linux? Well, it turns out that VMware supports SUSE Linux, Red Hat Linux, Ubuntu Linux, but primarily business releases. And CentOS, or CentOS, because it is rebadged Red Hat Enterprise Linux, is also supported. There is typically no support for hobby experimenter releases of Linux like Fedora, but with a little bit of effort they can be made to work as well. Other Linuxes that are supported include distributions like Asianix, Debian, and so on. Now, what else is supported? Well, NetWare. 5.1, 6.0, 6.5 are all fully supported by VMware, as is Solaris 10, both in 32 and 64-bit editions. Solaris 9 and 8 are supported experimentally, which means they're not officially supported for production, but they will work. Okay, what else is supported? Well, OpenServer 5 and UnixWare 7 from Santa Cruz Operation are supported. These are legacy Unix releases that were widely used in the 80s and 90s for Unix on Intel purposes. Now, other operating systems that are supported by VMware include FreeBSD, OS/2, and actually many others. And that's it. So if you have any questions or any comments, please feel free to use the questions and comments box. And thank you for your attention.